viewers, welcome to Brainiac. In today's video, we are going to focus on the discovery of protons and positive rays. Without further delay, let us go into the video. After the discovery of electron, the fundamental negatively charged particle in matter, scientists wondered the presence of positively charged fundamental particle in matter. That was because matter is electrically neutral. So, it should have both negative as well as positive fundamental particles whose charges are equal. A scientist known as Goldstein used, or rather replaced, the normal cathode with a perforated cathode to isolate the positively charged fundamental particle from matter. The apparatus he used is as follows. This was the setup used by Goldstein. The only difference here from the cathode ray experiment is that the cathode was replaced by a perforated cathode. A perforated cathode means a cathode with small holes. As Goldstein started the experiment, as usual, the cathode rays flowed through the anode. One thing you should look here is that the voltage applied was about 10,000 volts and the pressure was 0.01 Hg. That's a very low pressure. So, what he started to observe was, in the middle of the experiment, from the middle, there were some red colored glowing particles which started flowing towards the cathode. And then, it went through the perforated hole and then gave a glow at this point. Since these rays were moving from the anode to the cathode, Goldstein named these particles as anode rays or positive rays. Goldstein then changed the materials of the anode and cathode, and he could not see a difference in properties of positive rays. So he concluded that positive rays are generated from gas, and hence he named them as tube rays or canal rays. Like I said before, much later, J.J. Thomson tested the positive ray properties. And he observed 4 significant properties. The first property was, anode rays were positively charged. Hence, they deflect towards the negative plate in electric fields. The second property was, positive rays have mass, so it has momentum and kinetic energy. So positive rays can do a work. To prove this, we can use the same paddle wheel experiment done to the cathode rays. The third property was, positive rays deflect in magnetic fields, not towards north or south. It deflects perpendicularly in or out. This was proved according to Fleming's left-hand law. The fourth property was, properties of positive rays depend on the gas inside the tube. For that, J.J. Thomson used different types of gases like H2, the vapor of water, or nitrogen. And again, much later, you know this scientist, right? That's right, Rutherford. Rutherford obtained different positive ray particles by using different gases as tube gases. And he finally observed that hydrogen produces the smallest and lightest positive ray particles. Hence, he named the lightest positive ray particle as the proton. And it was also experimentally found that a proton was 1840 times heavier than an electron. And that's the end of this video. If you liked the video, please give it a thumbs up. And don't forget to subscribe to Brainiac. Leave your comments in the comment section below. And also do not forget to subscribe to our sponsors Funfetti Kitchen. Their link is also given in the description box. Subscribe to our channels and enjoy watching our videos. Thank you for watching and bye.